It's like uh, a rock that you try to roll off of the top of a hill. At first, maybe the rock stops when you stop pushing it, and then you push it a little more, and then you stop pushing it, and then the rock stops. But at some point, the slope gets steep enough that even though you stopped pushing the rock, it still goes. It rolls on its own, right? And that's called a runaway positive feedback.
If you unzip Thwaites Glacier far enough, it accesses that whole central region, and our best estimate now is that that is something like 12 feet of sea level rise.
We are possibly in a collapse right now, but I would say it's not very likely, but we can't completely rule it out either. The collapse process depends a lot on the nature of the bedrock topography underneath the glacier. And it just so happens that we have a very hard time mapping. I mean, we know more about the topography of Mars than we do about the topography beneath Antarctic ice.
Probably one of the places I'm most worried about in the whole climate system, the fact that we don't have enough observations along the coast of Antarctica.
A lot of this mass loss around Antarctica is because of increased ocean heat being delivered to these ice shelves. This increased ocean heat is likely due to increased greenhouse gas emissions from human activity.
The accident of where it is that Thwaites can cause tremendously more sea level rise by itself than these others have, because it opens into this huge area that can make giant icebergs.
And what we actually see is that due to the weakening over the last decades, this ice tongue is speeding up at the one side, not at the other side. And so basically the shear zone is tearing slowly apart. So you see a Sentinel-1 radar animation over Pine Island on the upper and Thwaites on the bottom. And you see, if you look at these zoom boxes, you actually see how these shear zones move from being almost intact, specifically for box P2 in the 2015s, to completely tearing apart, where you actually see that this whole shear zone is being ripped apart, with the result that you get all these small icebergs, and you actually see this process of where you are. I think it's kind of intuitive that you actually see how this shear zone completely disintegrates. It's still there, you still have these individual icebergs, but you see this damage occurring across this entire shear zone. And we kind of identify that as a potential feedback process. Due to the fact that things speed up, it breaks. And once it breaks, it's no longer able to kind of provide back stress to the fast moving ice.
Depending on what we humans do, sea level rise might be a couple of feet by 2100, it might be 1 foot, it might be 3 feet. You could jump it a little more above that. There have been some modeling exercises that have suggested maybe we've already reached the point that this will keep going. But a lot of the modeling says no, if we hold the warming to a small enough value, we stay here. And then sea level rise is small, slow, and expected.
Instead of retreating a few kilometers per year, suddenly we could stop for a while, stop retreating.
If it happens over 5,000 years, we can deal with it. That's slow enough that we can deal with it. But if it happens over 200 years, not so good. A gradual retreat, on the other hand, is something that could be stopped if we decide to, stop burning fossil fuels.
It's certain that the #1 control on what happens in the future is what people do. All of these different elements of the cryosphere, or frozen things, how they look in the future looks dramatically different if we are taking very strong action to reduce greenhouse gas emissions versus if we are following a path like today.